Welcome to this exclusive solution video. In question number 1, they have given some Venn diagrams which are not there anymore in additional math, but I'm still answering them because this can help you to understand them in extended or core math. So let's get started. We need to shade the region which represents the sets. So here they have given a set, rather a combination of sets where we will first focus on the brackets. Just like BEDMAS we will focus on this set, which is A union B. That means we have to shade A and B, their union. So this part is A, and if I add B to it, this becomes A union B, right? Just keep in mind that both the circles are shaded. Now, second part is that we have to shade the part which is common with C prime. So let me undo this and show you what is C prime. Just keep in mind this shaded part, right? Okay. So only C is not shaded, rest everything is shaded. Now you can see what is common in previous shading and this shading. This part, let me show you this part. Yeah, this one is shaded, this one is shaded, and this one is shaded in previous part also. This area becomes common between A union B and C prime. So finally, we will shade the parts which are like this. And here it is. This is the final answer of A union B intersection C prime. Alright, let's go to the next one, where you have intersection between B prime and A. That means any region outside B and A, what is common? So we'll focus on B prime first. So this part is not in B, this is not in B, this is not in B, and this is not in B. That means every area outside B will be shaded for B prime. Which of these ticks are also in A? Intersection means common between A and B prime. So these two, this one and this one, these two are in A as well as B prime. So now I will shade the one we want. Okay, here is the shading. So this is your final answer of A intersection B prime. Now union C, that means we have to add C to it, and C, we know that this part is C, this is C, and this is C. This will be C added. Union means shade that also, and this part was already shaded, others are also shaded. So this is the final answer of the whole expression. Here's the B part. Okay, in B part they have given again a Venn diagram and they are asking us to complete the following. First of all, number of items in P prime. How many numbers are outside P? So we will not count 7, 2, 8 and 1. We will count only 4 plus 3, 7 plus 6, 13 plus 5, 18. So answer is 18. Next one says number of items Q union R. What are the total number of items in Q union R, and then we'll find intersection with P. But because bracket is here, we'll answer the bracket first. Q union R. Q and R total, how many they have? 1 plus 6 7 plus 8 15 plus 3 18 plus 4 22 plus 2 24. These 7 and this 5 is not Q and in R, so we'll not count it. Out of these 24, how many are common with P? So this 2 is there in P, this 8 is also in P, and this 1 is also in P. So total 2 plus 8 plus 1, they are in previous counting as well as P. So 11 are the number of items common there, so it will be 11. Let's talk about the third one, Q prime union P. So we will have to see what is outside Q first. So outside Q will be 7 and 1, 8 plus 6, 14 plus 5, 19. So Q prime are 19. Union P, that means we'll add P to it. 7 and 1 of the P are already there, these two. What else we will add? This 2 and this 8, which is 10. So 19 was already there. This 10 is extra because it is in P, right? And P has to be there. So 19 plus 10 makes it 29. These are the three numbers. Question is answered. Moving on. Question number 2. Solve the equation absolute 3x minus 1, 5 plus x. Absolute again. Both sides are absolute. In such case, we don't know what is inside absolute. We know outside absolute, everything becomes positive. But what is inside is not sure. So there are four possibilities of this. Let me write 3x minus 1 and 5 plus x. It's possible that 3x minus 1 is negative inside and 5 plus x is also negative. It's possible that 3x minus 1 is negative but 5 plus x is positive inside. Right? Similarly, positive and negative is a possibility and positive is the fourth possibility. That means these are the combinations possible. Suppose both are negative. Isn't this exactly same as this particular combination? Because if they are both negative, we cancel negatives and it becomes positive. That means we can count them as both positive and discard this one. Similarly, when this is negative and this is positive and this is positive and this is negative, they are of opposite sign. They also are exactly same. So we can discard one of them. Right? So you can use either these two, 1 and 2, or you can use these two, the one remaining here, 1 and 2. I will use the one which are remaining here. Alright? What I mean is this. Let me use the first one, where this part becomes negative, that is minus 3x minus 1. That means 3x minus 1 becomes negative and 5 plus x is positive. Second one will be both are positive. So I will write this here after some gap. 3x minus 1, no change in sign. 5 plus x, no change in sign. Only this sign got changed. This is okay when there is an equal sign. In inequality, we have to be a little careful, but with equal sign, everything is okay. So let me solve this one. 3 minus 3x plus 1 equal to 5 plus x. Minus 3x and the plus x also comes to the left, equal to 5 minus 1 minus 4x equal to 4. So x becomes 4 divided by minus 4, which is minus 1. X equal to minus 1 is the solution of this combination or this combination. Both of them would give you, not this and this. Both of them would give you the same answer. Second is this one. So it will be 3x and this plus x comes to the left again, equal to 5 plus 1, 2x equal to 6, x equal to 6 over 2, that is 3. X equal to minus 1 and x equal to 3 are the two solutions of this particular equation which has absolute involved. If you want to test whether these answers are correct, just plug them in. Let me do it here. Let me plug in minus 1 in the absolutes and I will prove that this is a correct answer. Minus 1 equal to 5 plus minus 1 absolute. Okay, so this becomes minus 3 and minus 1 absolute equal to 5 minus 1, 4 absolute. See, this is 4, this is 4, they are equal. Similarly, if I use 3, that will also be proved. So 3 times 3 minus 1 equal to 5 plus 3. So 9 minus 1. 9 minus 1 is 8 absolute equal to 8 absolute. Perfectly alright. Both the answers are correct. You don't need to do all this. This is just for verification. I just want to give you full knowledge of the processes. So this is how it is done. Find integers p and q such that this is true. Alright. In such questions, we should always rationalize and combine one side because this is already in two parts and this is single part. So let's focus on only on the left side first, and then we'll see if we need a right side also. Alright, so p over square root 3 minus 1 plus 1 over square root 3 plus 1. We can see there are two of them. We want to combine them, so they should have same denominator, and we can see that their denominators are different. To make them same, just multiply this by the other denominator, which is kindly conjugate of this, which is kind of conjugate of this, and we'll multiply numerator as well by the same number, so that we effectively multiply by 1, we don't change the expression. So here we will multiply by square root 3 plus 1, and here also square root 3 plus 1 I multiplied with this one. So both of them have same denominator now, and you can see it is in the format of a plus b, a minus b. And the identity I repeatedly use in my videos is this: a plus b, a minus b. If this is the situation, it is always equal to a square minus b square. So what will this become? This first one, it will become p square root 3 plus 1. That's the numerator. And denominator, because of this identity, it will become square root 3 square minus 1 square. And same here, square root 3 minus 1, because there is no number here, just 1, so 1 will not make any difference. And square root 3 square minus 1 square. Okay, let's see if we can complete it here. P square root 3 plus 1 plus square root 3 minus 1 over. Now both of them have same denominator, that's why I drew a line, and the purpose was to combine the two, and that's what is happening here. Square and square root will cancel in both of them, so it becomes 3 minus 1. Okay, so what is the numerator now? If I open this bracket, I get p square root 3 plus p plus square root 3 minus 1 over 2. Now let's combine square root 3 and square root 3 together with this denominator. So square root 3 over 2, I wrote it for both of them, and p, and we have effectively 1 here, so p plus 1 we can write here. And what I left, p and minus 1, we will write them separate. P minus 1 divided by 2. And it is equal to, they gave us q plus 3 square root 3. What it means is that this has square root 3, it will be equal to 3 square root 3. So let's equate here to find the value of p. Square root 3 over 2 p plus 1 equal to 3 square root 3. A surd cannot become a complete number without multiplying something, and that's why I have equated a surd with a surd. That's what we should do whenever we have such a situation. And similarly, this is a perfect number without a surd, this will be equal to this. So p minus 1 over 2 is equal to q. They will give us the value. Now square root 3 are on both sides, we can cancel square root 3, and let's see, p plus 1 over 2 equal to 3. That gives us p plus 1 equal to 6. Yeah, this 2 multiplies with 3 gives us 6. And p is 6 minus 1, which is 5. And here we'll write the value of p so that we get q. 5 minus 1 over 2 equal to q. 4 divided by 2, 2. Q is 2. P is 5. Let's move on to the next one. Solve the simultaneous equations. Okay, again simultaneous equation, but in logs. Since all of them have log base 3, let's convert the ones which don't have log base 3 to log base 3 so that we can combine them. Okay, so left side of equation number 1, log base 3 x plus 1, it is already log base 3, don't touch it, equal to this one. Can I write this as log base 3 3? How? Log means we want to know what exponent of the base is the main number. So what exponent of 3 is 3? 1. That's how this 1 is converted to log base 3 3 plus log base 3 y. This becomes Equation number 1, all parts have logs. Let's combine these two, okay, because they are addition in between. So log base 3 x plus 1 equal to log base 3. Whenever two logs have an addition sign in between, the logarithmic law says you can multiply the contents of the log. So 3 times y, 3y. That's what it becomes. Now both of them are log base 3. We can neutralize logs. So it gives us a simple equation, x plus 1 equal to 3y. This is equation number 1. Let's go to this one. Log base 3 again, x minus y equal to, now again I have to convert it to log base 3. What is the 2 exponent of 3? That's what it means. We have to write that here. 2 exponent of 3 means 3 square. So we have to write here 9. Look here, it was log base 3 because we had a 1 here. So 3 to the power 1 is 3. Similarly, in this case, 3 to the power 2 is 9. That's what we write here. So we converted an exponent into log. So now both of them have log again. So this becomes our second equation, which is x minus y equal to 9. Let's isolate x in this. 9 plus y and substitute here in this equation. 9 plus y plus 1 equal to 3y. Let's bring 3y with y. Y minus 3y equal to minus 1 minus 9. Minus 2y equal to minus 10. Y equal to minus 10 over minus 2. Negative and negative cancel out. Y is equal to 5. To find x, we'll substitute it here. X equal to 9 plus 5, which is 14. X is 14, y is, we got 5. The diagram shows points OA, B, C, D, and X. The position vectors of A, B, C relative to O are given here in terms of A, B. The vector CD is 3A. Alright, so let's try to confirm what they're talking about. OA, this vector is A, OB is B, OC is 3 over 2, 1.5 times B. That means this, if it is 2 ratio, it is 2 ratio 1. That's how it becomes total 3, and this is 2, 3 over 2. This OC becomes 3 over 2. Alright. Vector CD, C and D is 3A. That means it is parallel. If it is multiple of A, that means OC and rather OA and CD are parallel to each other, and the magnitude of CD is 3 times A. That's what it means. If OX is lambda OD, OX is lambda OD, that OX we can see is much smaller than OD. That means lambda is less than 1. That's what we should keep in mind. Then only it can be so short. Alright. Express OX in terms of lambda, A and B. So they have already given OX in terms of lambda. That means OD. We have to take care of OD. So let's write OX equal to lambda. Now OD. O is here, D is here. I do not want to go directly to D from O. So I will go this way to OC. So in place of OD, I can write OC plus CD. Yeah, OC and then CD makes it OD in vectors, right? OC, they have given already 3 over 2b. So lambda 3 over 2b plus CD, they have already given 3a. And done. OX is in terms of lambda, A and B. We got it. That's why it is just 1 mark. Next part. AX is mu times AB. AX is this one, small one is mu times AB. Again, that means mu is also less than 1. So, express OX in terms of mu, A and B. That means we have to take help of AX. Alright, OX we want So OX is equal to, so O to X, we have to reach X from O involving A and B. So I will go to OA because I need to involve mu. I'll go through AX. So can I write this as OA plus AX plus AX? So OA we already know is A plus AX, they have given mu AB. Okay, that means we have to convert AB also in terms of A and B. So AB, A is here, B is here. So if I want to involve A and B, I will go to AO and then go to OB. So I can write A plus mu AO plus OB. Alright, AO is minus A. Can you see? AO is minus A because OA is A, so AO will be negative A. And from O to B, we have B. So negative A plus B, that's what it becomes. So OX becomes A plus mu minus A plus B. Usually we don't write negative first, so let me rearrange it and that will become A plus mu B minus A. This is OX. Now let's move on to the next one. And here it is. Use your two expressions for OX to find the value of lambda and mu. Since this is equal to OX, this equation is also equal to OX, we can equate them. So let me write this equal to lambda 3 over 2b plus 3a. This was what we got earlier. So let's expand the two sides. This will become a plus mu b minus mu a equal to 3 over 2 lambda b plus 3 lambda a. Let's combine this a and this a. And there's a purpose behind that. I will tell you what. 1 minus mu. Yeah, this and this. I took a common. It became 1 minus mu plus mu b equal to 3 over 2 lambda b plus 3 lambda a. Now in vectors there is a rule that since a and b are in different directions, they cannot be a multiple of each other. They cannot be converted straightforwardly with a constant into other. That means in our equation, whatever we have a here, it cannot become this b or this b. That means this 1 minus mu must be equal to 3 lambda. Must be. Then only a will be equal to something times a. So that's what we do in every vector equation whenever we did something like this in previous Surd equation also. So same thing we are doing here. So 1 minus mu, which is with a, 3 lambda which is with a, they are equated and a is ignored. This becomes our one equation. So we can write isolate mu here. 1 minus 3 lambda equal to mu. I rearrange this so that mu comes in terms of lambda. Now here mu will be equal to 3 over 2 lambda. Can you see? Now both of them are in terms of mu on one side. So I can equate the other sides. Let me equate 1 minus 3 lambda equal to 3 over 2 lambda. So let me bring 3 lambda here. 1 equal to 3 over 2 lambda plus 3 lambda. Remember, initially I wrote lambda should be less than 1, right? Given based on their situations, we said we should get a less than 1 value. And here, if I get less than 1 value, my answer is perfect. So 3 over 2 times plus 3 will be 6 plus 3, 9 over 2. 1 equal to 9 over 2 lambda, and if I cross multiply here, lambda will be basically reciprocate both sides, 2 over 9. Yeah, cross multiply, this 2 goes multiplies with 1, 9 comes and becomes denominator, and lambda becomes 2, 9 which is less than 1, perfect. Let's find mu also. So mu is 3 over 2 times 2 over 9. 2 and 2 cancel here, 3 and 9 cancel, mu is 1 over 3, lambda was 2 over 9. We evaluated both. There are more parts to this. Find the ratio ax over xb. Ax over xb. This is ax, this is xb. So we want their ratios, and we already know this expression they gave us. Ax is equal to mu ab, and this will help us to find the ratio. What was mu equal to? 1 over 3. So ax equal to 1 over 3 of AB. This means it is 1/3 of this whole of it. So that means if this whole of it is in 3 units, we have 1 unit with x. So if we have 1 unit here, how many units will be here? 2. Yeah? Then only it becomes 3 total, and ax becomes 1/3. And that's what we will write. Ax over xb. Ax over xb will be 1 over 2, because ax is 1 unit, xb is 2 unit. That is the answer. And how do we mathematically show this actually? So ax is 1/3 of ab. We know that, right? Divided by xb can be written as ab minus ax, isn't it? This is logical answer. I'm trying to show it mathematically. 1 over 3 AB equal to AB minus 1 over 3 AB, right? Which is 2 over 3. 1 minus 1/3 will be 2/3. So 1 over 3rd AB equal to 2 over 3rd AB. AB and AB cancel. 1 over 3 divided by 2 over 3 will be like this. 1 over 3 divided by 2 over 3. So 1 over 3 multiplied with 3 over 2. And this cancel. Answer is 1 over 2, which we showed logically earlier. We have shown that mathematically here. What is the next one? OX ratio XD is also to be shown. Okay, OX XD. OX is this one, and XD is this one. And they have already given OX is lambda OD, and we know that OX was 2/9, lambda was 2/9 of OD, so we can use it. OX and OD same thing. But now I will use straight away mathematical, not the logical way. So OX equal to 2/9 of OD, because lambda was 2/9, right? So OX over OD can be written as 2/9 of OD divided by XD was OD minus OX. So what will that be? 2/9 of OD, 2/9 equal to OD minus 2/9 of OD, right? So it becomes 2/9 of OD, and 1 minus 2/9 will be 7/9 of OD. OD and OD cancel. 2/9 over 7/9. 2/9 divided by 7/9, which can be written as 2/9 multiplied by 9/7. 9/9 cancel. Answer is 2 over 7. So OX over OD is 2 over 7. Done. Let's move on to the next one. The function f and g are defined for real values of x, and these are the functions. Find f square minus 3. It is not actually f square, it is f minus 3, which means that find out f of minus 3. So let's evaluate f minus 3, and then we will go ahead. Let's write here f minus 3. So f minus 3 will be, in place of x, we will write minus 3 here. So minus 3 plus 2 square plus 1. This is minus 1. Minus 1 square is 1, and 1 plus 1 is 2. So f of f minus 3 is actually f2. That's what they're asking us to evaluate, and we'll do the same way we did here. it will be 2 plus 2 square plus 1. So 4 square is 16 plus 1, 17. So f square minus 3 is finally 17. Okay, what next? So that the inverse of gx is gx itself. Wow, that is interesting. So let's do it. Gx is this. So in place of gx, we'll write y equal to x minus 2 over 2x minus 1. X is not equal to half. So to find inverse, we reverse x's and y's. They interchange their places. So x equal to y minus 2 and 2y minus 1, and we have to isolate y, make y the subject now. And for that, we have to combine these two, and for that, first step should be to cross multiply. So x will multiply with 2y minus 1, which is equal to minus y minus 2. So if we open the bracket here, it becomes 2xy minus x equal to y minus 2. This x will go to the right side and this y will come to the left side, so that we can isolate y. 2xy remains here, this y comes here, x goes to the right side, and we already had minus 2 here. Now we can take y common out of these. We will be left with 2x minus 1, which is equal to x minus 2. And if I divide both sides by 2x minus 1 to get rid of this 2x minus 1, we'll get y equal to y minus x minus 2 over 2x minus 1. And look, it is exactly what gx was. So this g inverse x is actually equal to gx itself. Let's move on to the next one, which is this. Solve g of x equal to 8 over 19. So g of x means g of fx equal to 8 over 19. Okay, so inside the function g we have to put fx. So I can write this as g, and what was fx? Fx was x plus 2 square plus 1. X plus 2 square plus 1 equal to 8 over 19, not 9, 19. Okay, so wherever in gx we have x, we'll substitute that x by this big expression. So we got gx in the previous part right here. So let's use this one. So let's write here. X, this is the x which will be replaced by this whole thing. X plus 2 square plus 1, and then we had minus 2 over 2, again second x will also be replaced by the same x plus 2 square, rather I have to put a bigger one here, plus 1, and then we have minus 1 also. This we have to simplify. Let me copy this and move it to somewhere else. So pasted, and we'll have to make it equal to 8 over 19. So we can bring this here and multiply this here. Okay, so 19 multiplied by, I'll open this one, x plus 2 whole square will be the square of x plus the square of 2 plus 2 times 2x. That's the expansion of x, a plus b whole square, right? A square plus b square plus 2ab. Then we'll have plus, okay, 1 minus 2 will be minus 1. So let's write minus 1 only. Equal to 8 is already here, and this will come here, and 2 comes first, and then comes what is inside bracket. Again, same thing, x square plus 2 square plus 2 times 2x is this one, and plus 1 is also multiplying with 2 plus 1. That means this bracket is not needed, and 2 will multiply with this one, and 8 multiplies with minus 1 only, alone. I hope you understand very clearly here. This 2 was with this bracket only, so this 2 has to be with the bracket, and minus 1 does not multiply with 2, minus 1 is outside, it multiplies only with 8. So let's open the both brackets and we'll get it. 19x square, and this is 4. 90 times 4 is 76, and 4x becomes 76x. In this case, 19 multiplies with whole of it. Then minus 19, okay, plus, rather equal to 8. 2 times x square is 2x square, 2 times 4 is 8, 2 times 4x is 8x, and then 2 times 1 is 2, and then we have minus 1, and it will be double bracket here. Okay, 19x square plus, okay, 70, this is 9, this is 76, it's not 9, 19. 76 minus 19 will be 57, plus 76x equal to 8 times 2x square is 16x square. 8 times 8, rather we can, 8 plus 2, 10, right? Yeah. So 10 and minus 1 can be combined with 9. 9 times 8 is 72. So this has been taken care of, this has been taken care of, this has been taken care of. 8 times 8 is 64x. Alright, let's put everything to the left side. 19x square minus 16x square plus 57 minus 72 plus 76x minus 64x equal to 0. 19 minus 16, 3x square. 57 minus 72 will be minus 15. 76 minus 64 will be 12x equal to 0. All of them are multiples of 3. Divide by 3. The whole equation becomes x square. Minus 15 over 3 is minus 5. Let me write it later and write x first. For 12x over 3 is 4x equal to 0. And I can do it mentally. You can use your calculator to find the value of x here. It will be x plus 5, x minus 1 equal to 0. This gives you x plus 5 equal to 0, which is x equal to minus 5. This one will give you x minus 1 equal to 0, x equal to 1. So these are the two solutions of the given situation. Question number 7. A particle is moving in a straight line, passes through a fixed point. Its velocity v meters per second, t seconds after passing O is given by this. This is the velocity after leaving O. Okay. Find the value of t when the particle is first at rest. First of all, we should know that at rest means velocity is 0. The thing is not moving, that means v is 0. At first, they said, first means the first answer, or we'll get multiple answer, but first answer after t equal to 0 will be the answer we will accept. That's how we interpret this. Okay, so we'll make this v equal to 0 and we'll write rest of the equation. 3 cos 2t minus 1. Okay, let's put 1 on the other side. 1 equal to 3 cos 2t, and divide both sides by 3. We get cos 2t equal to 1 over 3, since this 3 and 3 cancel out. So 2t is cos inverse 1 over 3. Since we are concerned with the first answer only, and this is cos is positive in this quadrant, first and fourth. So we will take only the first quadrant, we will not look at the second quadrant. So now we will put cos inverse 1 over 3 in our calculator and we'll find the value of this particular right side part. By the time I do this, I would request you to subscribe to my channel Like this video, share with your friends so that they also get benefited, and I'm motivated to make more videos to spread this knowledge. Thank you very much. When I use my calculator, I got 2t equal to cos inverse 1 over 3, 1.23. In that case, t will be 1.23 divided by 2. I would like to mention here that we always, whenever we find the inverse of any trigonometric ratio in the situation when the motion is in a straight line, this kind of situation, we always use radians, never use degrees. It will give you a very high number which will be wrong. So just take care of that point. So the final answer we got 1 over 1.23 will be 0.615 seconds. This is the time when the particle was at rest for the first time. Let's see what is second part saying. Find the displacement from O of the particle when t is pi by 4. Displacement, okay? For displacement, we need to integrate the velocity equation. Then only we get displacement equation. So let's integrate the left side as well as the right side. 3 cos 2t minus 1 dt. Okay, so integration of velocity gives us displacement which we show with s. 3 is a constant, so we will not touch it, but cos 2t, if I integrate cos 2t, it will be sine 2t divided by the differentiation of the angle. Differentiation of 2t is 2. Minus 1, the integration of 1 is t. And we write c additionally. Alright, so we have to evaluate c because we have to substitute t equal to pi by 4. Before that, we have to evaluate c. We know that this particle left the point O, so at point O time was 0. Time started counting from here and displacement was 0. And since our equation is in terms of s and t, we will use this situation in the given equation. So 0 equal to 3 sine 2 times 0 over 2 minus 0 plus c. Everything is 0. This is 0. Sine 0. This will become sine 0 will be 0. So c is 0. So c is insignificant here. Even though it was 0, but you must show the process all the times. Okay? So our equation becomes s equal to 3 sine 2t over 2 minus t. That's it. And now they're saying when t equal to pi by 4, find the displacement. So we'll just substitute t equal to pi by 4 here. So displacement then will be 3 times sine 2 pi over 4 over 2 minus pi over 4. Okay, so it will be 2 and 4 cancel. Sine pi by 2 is 1, so it will be 3 over 2 minus pi by 4, the exact form of displacement. But if you want to convert it into decimals, you can do that. Let me also do it. And I got it equal to 0.715 meters. Let's go to the next part. Find the acceleration of the particle when it is first at rest. So we already know that the time when it was first at rest was 0.615. This was the time we got in first part. Now we want to find acceleration. For acceleration, we differentiate the velocity equation, which was 3 cos 2t minus 1. For displacement, we integrated. For acceleration, we will differentiate. dv over dt is equal to 3 is 3. I did not touch it. The differentiation of cos is minus sine 2t. And further, we have to multiply by the differentiation of the angle 2. In integration, we divided. Here we multiply. Okay, and the differentiation of minus 1 is 0, so there is no need to write it. We'll just simplify this. Minus 6 sine 2t. And now in place of t, we will use the time we got earlier. So at t equal to 0.615. This is acceleration. Acceleration will be minus 6 sine to 0.615, and I get minus 5.66 meters per second square. That's the unit of acceleration. And negative means it is actually deceleration. Its speed is reducing. Question number 8. A man who can row a boat 3 meters per second, okay, they have shown it here, in still water, wants to cross the river from A to B, okay, straight, shown in the diagram. It is perpendicular to the banks. We can see that it is 90 degree. Okay, the river, which is 50 meters wide, okay, is flowing at a rate of 1 meter per second, shown here in the direction shown. The man points his boat at angle alpha degree to the bank. Find the angle alpha. Okay, so we know that finally his motion in this direction will be actually the resultant of his motion where he's trying in this direction and the river flowing in this direction, and this triangle will be formed by the vectors 3 meters per second his own speed and the speed of the boat 1 meter per second in this direction, and which will result that he reaches at B point at a straight line, because we know that if two vectors are added head to tail, the third vector which joins the tail of the first to the head of the second becomes the resultant, and this is the resultant we want, right? They're saying find the angle alpha. So since we know this is 3 meters per second, this is 1 meter per second, we can find this angle, can't we? Let's call this angle as theta, and we know that alpha plus theta will be 90 degrees, correct? So let's write theta first. For theta, this is opposite side 1. So sine theta equal to 1, opposite over hypotenuse is 3. So theta becomes sine inverse 1 over 3. And here we can say that alpha is 90 minus theta, and we can substitute theta by its value now. We know the value sine inverse 1 over 3. This is minus. And if we use our calculator, we get 70.528. And to round off this to 3 significant figures, it will be 70.5 degrees. That is the value of alpha. Let's see what is the next part of this. The resultant speed of the boat A to B. We have to find resultant speed. Since we know the angle now, we can find the resultant speed. Rather, since we know two speeds, let's say this is the speed 3 and this is the speed 1. So we don't even need angle for this. This is 90 degree. So we can use Pythagorean theorem in this case. So let's call that is x meters per second, the resultant. So x square plus 1 square equal to 3 square. X square equal to 3 square is 9 minus 1. X square is 8, and we square root both sides. We will not write the negative because it is going in the positive direction. X equal to square root 8 meters per second, and in decimal it is 2.83 meters per second. We have another part that find the time taken for the boat to travel from A to B. So we know that the distance from A to B is 50 meters, right? They've given here in the picture, yes, 50 meters. And we just found out the speed. So we know that time is equal to distance over speed. So distance is 50 meters, speed we just got 2.83 meters per second. And if we divide it, we get 17.7 seconds it will take to cross the river. Okay, next one. On another occasion, the a man points the board in the same direction again. Same direction. Let's draw it. So this is the direction. This was 70.5 degrees. That means this will be something else. Okay. And the river speed has increased to 1.8. So it will not be 1 actually now. It will be 1.8 meters. That means 0.8 meters extra, which will let it go to point C. So it will not reach to B because river flow is faster. It will reach beyond this. So he will go this way. The question initially says, state the time taken for the boat to travel from A, this is A, to C, this one. Okay, one thing we should be aware that time, because it's a straight line, I can write this as displacement, which is AC, over velocity, which we don't know now, because earlier we found it earlier, but now we don't know. So this same drawing is used for displacement as well as velocity. That means their ratio remains constant all the time. So the time that it will take to reach from A to C will also be same what we got in previous part, 17.7 seconds. And reason is this. The ratio always remains same. Practically you see, it became faster. So the boat was pushed in this direction and it traveled a longer distance. Since it traveled a longer distance, its speed, resultant speed will also increase in that ratio, and that's why the time will stay the same. For that matter, if it was very fast and it would reach here somewhere here, still the time would be 17.7 seconds, as long as the original speed remains 3 meters per second. All right, there should not be any change to this one, otherwise there will be a problem. All right, second part of this is saying hence find the distance BC. Since we know the time now, if we somehow find this velocity here V, we'll find the total distance AC. And now for that we can do what we can, this is the bank of the river, this angle is 70.5. So this angle will also be 70.5 because this is alternate angle, right? And with the help of this angle, we can find V by using cosine law. By cosine law, V square will be equal to 3 square plus 1.8 square minus 2 times 3 times 1.8 cos and 70.5 degrees. Always in cosine rule, keep in mind that this angle must be equal to this particular alphabet. All right. So V comes out to be square root 3 square plus 3 square can be written as 9. Rather, let me leave everything to my calculator, but for the sake of writing, just I'm writing it. 3.24 plus 18. Okay, they're done. 6 times 18, 10, 108, 10.8 cos 70.5. Let me put this whole thing in my calculator and I will get my answer. What I'm getting here is 2.94, almost 4 meters per second. I'm not rounding this off. This is for the sake of rounding off. Otherwise, I will not round it in my calculator because my answer has to be as accurate as possible. Now, distance AC will be the time taken, basically this one. Velocity will multiply with time and give us displacement. Time taken multiplied by the speed, we got 2.94. Time was 17.7. We already write 2.94. And this is not actual time, okay? Almost 52 meters. So this distance AC is 52 meters. But they're asking us BC, from B to C, this distance. So we already know that this distance is 50, that is 52. So I think we'll get it now. Let's redraw this. Here this is 52, this is 50. We want to find this. Let's call it Y. So by Pythagorean theorem, 50 square plus Y square equal to 52 square y square equal to square, not square root, 52 square minus 50 square and square root both sides to get the value of y. It comes out to be about 14.2 meters. That is BC. Question 9. Show that the differentiation of this is this. Very straightforward question. We can do that. Basically, they're asking us the differentiation of ln x over x cube. So we will use quotient rule in this. So for quotient rule, we square the denominator first, then we write the same denominator, and then we differentiate the numerator. The differentiation of ln x is 1 over x minus, then we write ln x, that means the numerator, and differentiate the denominator, which is 3x square. So this x and this q will cancel, will be left with 2, and both the parts have x square. Can you see here? So we can write x square, and nothing is left here, only 1 is left, minus 3 is left here, and ln x, 3 ln x over x to the power, x cube square will be x to the power 6, and this square again cancels with this 6, we're left with 4, and finally what they wanted, 1 minus 3 ln x over x to the power 4. Part 2. Find the exact coordinates of the stationary point of the curve y equal to ln x over x cube. Ln x over x cube. Okay, so basically what we have differentiated, we will equate it to 0 and we'll get the stationary point, the x coordinate. They're saying exact coordinates. That means once we get x, we'll get y also. But let's do the needful first, which is the differentiation we just got equal to 0. 1 minus 3 ln x over x to the power 4 equal to 0 for stationary point. And when x4 goes and multiplies with 0, we are left with 1 minus 3 ln x equal to 0. Let's make this 3 as exponent of x. So we can do that by law of logarithm. Ln x cube equal to 0. So let's take ln x cube to the right side, and we are left with ln x cube equal to 1. Alright, so now if we want to get rid of this ln, the other side should become e to the power. So e to the power 1 equal to x cube, and if we cube root both sides, e to the power cube root to the power e equal to x, or if you want to write x equal to e to the power cube root is also written as 1 over 3. This is the x coordinate. Let's find y coordinate. For y coordinate, we will just substitute this into the main equation, y equal to ln x over x cube. Y equal to ln x. X for us is e to the power 1/3 now over x cube, e to the power 1/3 cube. So ln and e neutralize each other. We are left with 1 over 3, and e to the power 1/3 to the power 3rd, again the exponents multiply, they cancel out, so we just left with e. So 1 over 3 e, because e was a denominator, so I wrote it with the denominator. So the coordinates of the stationary point are e to the power 1/3 comma 1 over 3e. Move on to the next part. Use the result in part 1. Okay, what was the result in part 1? 1 minus 3 ln x over x4. Okay, find the integration of ln x over x to the power 4. Okay, so this is our question, 1 over ln x over x to the power 4 dx. Correct? Let's call it I. This is the integration we want. And in first part, we got the equation that ln x over x to the power 3, its differentiation was 1 minus 3 ln x over x to the power 4. So if I integrate this, won't I get this? I will, because integration is inverse of uh, differentiation. That's why it's called antiderivative. But it does not match with our question. How about this? I change this one to 1 over x4 dx minus 3 ln x over x4 dx. Can I do that? I separated the numerators of this and they became two separate questions. So if I integrate these two, I will get it is equal to ln x over x cube, our original question. This one will be the answer if I integrate this whole thing, which is this. Out of this, don't you think this is our I, the one I have just assumed as I. So in place of this, let me write I. Let me rewrite the whole thing now. Integration of 1 over x4 dx. This one I'm writing, okay? This whole thing I'm writing. Minus 3I, because this is our question I, which I assumed as I, equal to ln x over x cube. Right? Now, I is the one we are interested in. So what will we do? I'll bring this to the left side and 3I to the right side so that I can isolate I somehow and I'll get its value. So integration of x to the power minus 4, I'm changing it so that I can integrate it easily. 1 over x to the power 4, I'm writing this as x power minus 4 dx minus ln x over x cube. It is without integration, right? Because this was the original question, if you remember, equal to 3I, right? Let me integrate this. It becomes x to the power minus 4 plus 1 divided by minus 4 plus 1. This need not to be integrated because it is not integration, it is simple expression, equal to 3I. So it becomes x to the power minus 3 over minus 3 minus ln x over x cube equal to 3I. Now, to get rid of this 3, because I'm interested in I, not in 3I. So I'll divide by 3 here, I'll divide by 3 here, I'll divide by 3 here. I multiply the denominator by 3, that is equivalent to dividing by 3. And the final answer will be 3 and 3 cancel out. This will be minus 1 over 9 x cube. Why? Because this minus 3, when you want to make it positive, it comes and becomes denominator along with the 9. So this is what the first part is. Second one is fixed, minus ln x over 3x cube. It is equal to I. This becomes our answer. Question number 10a is an identity. We have to prove this. Before I solve this, I would like to inform you that I have prepared some videos on tips and tricks to prove identities, and additionally I have proved all the identities of the textbooks of additional math. I would like you to watch them. I will give the link to the playlist in the description and you can watch them. And I assure you that you'll be more successful in proving identities if you watch those videos. So let me do this one. Sin x over 1 plus cos x, and let me give some space because I'm going to do something. 1 plus cos x over sin x, and this is our left hand side. We have to prove this is equal to right hand side. I left this space because I want to multiply the denominator of this by the other denominator, which is sin x, right? And I will multiply this sin x by the one on the other side, which is 1 plus cos x. And we can't do it free of cost. We have to compensate them by multiplying same up also. So I'll multiply here by sin x as well. So since the denominators are same now, I can write them as one term, 1 plus cos x, sin x being the denominator, and it will be sin square x here plus 1 plus cos x, 1 plus cos x. That means it is 1 plus cos x whole square. So if I expand that, it becomes 1 plus cos square x plus 2 cos x. Okay, so now we know that sine square x plus cos square x is 1, isn't it? And we have one more, so it becomes 2. 2 plus 2 cos x over 1 plus cos x sin x. So we can take 2 common out of these two on numerator. What is left? 1 plus cos x, and we already have 1 plus cos x sin x in the denominator. 1 plus cos x and 1 plus cos x cancel out. What are we left with? 2 over sin x, which is 2 cosecant x, and this was the right hand side. We proved it. Left hand side is equal to right hand side. Identity proven. Going on to the B part, which has nothing to do with A part. In this, they're asking us to solve the equation. Don't get surprised. In place of x, we have y. We don't have any theta. Doesn't matter because we want an answer between 0 and 360 degrees. So we'll just treat it like a normal equation. All right. To solve any trigonometric equation, we must have same ratio throughout, cot and cosecant. Either convert cosecant into cot or cot into cosecant, or both of them into some third ratio which is same. But the best one would be that cot square y. There is an identity that 1 plus cot square theta equal to cosecant square theta. This is an identity, and that's what I'm going to use, because cot square theta will become cosecant square theta minus 1 according to this, and that's what I'm going to change this cot square y as. So cosecant square y minus 1 plus cosec y minus 5 equal to 0, and cosecant square y plus cosecant y, and we have minus 1 and minus 5, which becomes minus 6 equal to 0. This becomes our equation which has same ratio. So let's assume cosecant y equal to say t. So it becomes t square plus t minus 6 equal to 0, and simple quadratic equation which can be solved by factoring. Let me factor this directly. You can use your calculator. It will be t square plus 3, not t square, t plus 3, and t minus 2 equal to 0. So it gives us t equal to t plus 3 equal to 0. T is minus 3. This gives you t minus 2 equal to 0. T is 2. Since this was our assumption, so we will use the first answer as cosecant y is equal to minus 3. Second one, cosecant y equal to 2. So we could have done y equal to cosecant inverse minus 3, but the problem is our calculators don't have cosecant. So what we have to do, we have to write the equivalent of this. 1 over sine y, that is cosecant y, equal to minus 3. And here 1 over sine y equal to 2. And now we can reciprocate both sides to get simple sine y. So I reciprocated this one. I will have to do the same here. I reciprocate this one. I have to do the same here. Now we get our two answers. Let's do the first one here. Y equal to sine inverse negative 1 over 3. Since sine is negative, we have to go to the quadrants where sine is negative. It is negative in third and fourth quadrant. So to get the acute angle, these two acute angles, we don't have to enter minus in our calculators anymore. Just put sine inverse 1 over 3, and that will be the acute angle this. Let me do it myself. So I got 19.47, and 19.47. Same angle will be written with the horizontal lines only, and the final answer will be, first answer for this will be the angle which is starting from 0 and reaching this line here. So it is crossing 180 degrees, right? So your answer will be 180 plus 19.47, that is 199.47, and we can round it off to one decimal place, 199.5 degrees. Let's talk about the second answer. Y2 will be continuing and reaching this line, which is not reaching 360 degrees, 19.47, lesser than 360 degrees. So we will write 360 minus 19.47, and that will be 340.53, which can be written as 340.5 degrees. Let's go to the second one. Second one will also give us two answers. This one, y equal to sine inverse half. In this case, sine is positive. That means it will be in the first two quadrants where sine is positive, and we will write sine inverse half. There is no negative, so we don't have to worry. Sine inverse half is 30 degrees. So we will write 30 here and 30 here. So the first answer will be from here till here, which will be y3 for us, which is just 30 degrees. y4 will be 180 minus 30 degrees, because it is not reaching 180, 30 degrees before that, 150 degrees. So these are the four answers. Moving on, we have another part for this, and it is also an equation, but here we don't have to convert it to anything else, because it is simply cos some angle equal to negative square root 3 over 2. So we know cos is negative in two quadrants, which are second and third quadrant, and we have to give our answers between 0 and pi. But whenever you have a coefficient with the angle and some other angle adding, always cross the limits. What do I mean by cross the limits? First of all, what is cos inverse square root 3 over 2? Again, I did not write negative here because negative has given us quadrant. Forget negative now. Cos inverse negative square root 3 over 2 will be pi over 6. Okay, so I will write pi over 6 here and pi over 6 here. Since I said whenever we have this abnormal kind of angle, always cross the limits. So this is 0. I will go to this angle as usual. Then I will go to this angle as usual. But I will again go to the third time to same angle again. I will go there as well. So maybe that will give us some answer. But let me start with the first one, which is this one. 2z. So first answer, 2z1 plus pi by 4 rather, pi by 4 is equal to cos inverse minus square root 3 has given us pi by 6, right? But the angle starting from here will be, this angle is pi, which is equivalent to 180 degrees. So pi by 6 is, this line is pi by 6 lesser. So we will write pi minus pi by 6. Alright, so 2z1 equal to, or rather, yeah, pi minus pi by 6 minus pi by 4. So let's see what it gives us. 12 is the LCM. So it becomes 2 over 12. This becomes 3 over 12. So 12 minus 2 is 10. 10 minus 3 is 7. 7 over 12, which is 0, between 0 and pi. That's good. So 2z1 becomes 7 pi by 12. So we'll divide both sides by 2. So we get z1 equal to 7 pi over 24, which is positive, which means 0 and pi, perfect. Let's go to second angle, which will be, let me change the color, which will be starting from 0 and reaching this. And that angle is pi plus pi by 6. Okay, so 2z2 plus pi by 4 equal to pi plus pi by 6. So 2z2 equal to pi plus pi by 6 minus pi by 4. Again, the LCM is 12. So I will make changes. If you're not comfortable with these kind of mental ways of solving, please use your calculator as usual. There's no problem. I'm just trying to save my time by accessing my calculator, punching numbers and doing it. I can do it mentally. So 2z2 is equal to 12 minus, no, plus 2. 14, 14 minus 3, 11. Pi over 12. That comes out to be how much? Z2 equal to 11 pi over 24. And that is okay. That is positive and less than pi. Then I said cross the limits. So let's cross the limit by going in positive direction again. Because I can't go negative. If I go negative, I'll get a negative answer which is less than 0. So I'm not going negative way. I'm going positive way just to make sure that I don't lose any answer. So I will go till here pi and 3 pi. Can you see? It is 3 pi up to here. 2 pi plus pi is 3 pi. And pi by 6 less than that. So let's see if that gives us an answer. Let's see. 2z3 plus pi by 4 equal to 3 pi minus pi by 6. So 2z3 equal to 3 pi minus pi by 6 minus pi by 4. So 12 and this becomes 36. 12 to 12, 3. So it becomes 2z3 equal to 36 minus 2, 34 minus 3, 31 over 12. Okay, pi. And z3 equal to 31 over 24 pi, which is greater than pi. That means this whole effort was useless, but I don't regret, because we should always cross the limits whenever the angle is abnormal. So our answers are these two only, 7 pi by 24 and 11 pi by 24. Let's move on to the last question of this exam. The cubic equation, this one has a repeated positive integer root. Okay, repeated positive integer root. So whatever is the root, it is basically, if I convert it to a factor, it will be squared or cubed, whatever is the situation. All right, that's what it means, and it's an integer. Okay, if the repeated root is x equal to 3, find the other positive. Okay, that means it is repeated twice. So x equal to 3 is the root. So if I convert it to the factor, it becomes x minus 3. That's how it becomes. And because there is a third positive root also, that means it is squared. It can't be cubed, because a cubic equation can have only 3 solutions. 2 are these 3's and there will be one more. Okay. Find the other positive root and the value of a or b. Positive root. Okay, so let's say that that positive root is x minus a. No, ab is used already. So let's write m. X minus m. Okay, so since it is also a positive root, so that means the constant part of their multiplication will be 3 minus 3 rather. Minus 3 times minus 3, because twice of this, and times minus m. Right? That will be equal to minus 36. This one. Right? So that becomes negative 9m equal to negative 36. They become positive. M equal to 36 over 9, which is equal to 4. The 4 is the third root. So the complete factor of this will be x minus 3, x minus 3, and x minus 4, where x minus 3 and x minus 3 make it a square. Now they're saying find the values of a and b. So if we expand this, we'll get the values of a and b. So let me expand these two, which is the square of x minus 3, x square minus 6x plus 9 times x minus 4. Okay, x square times x will be x cube minus 4x square minus 6x square plus 24x plus 9x minus 36 equal to 0. So if we simplify this, it will be x cube and minus 10x square, 24 plus 9, 33x minus 36 equal to 0. And now we can compare with the main equation given, and it is ax square. So a is minus 10, b is plus 33. A is minus 10, b is 33. I hope x square has a positive. Yeah, it has a positive. So these are the two values of a and b. Next part. There are other possible values of a and b for which the cubic equation has a repeated positive integer root. Okay. In each of these cases, state all three integer roots of the equation. So we don't have to find the a and b value. So we will just find the roots. Okay. So in case of the first part, we found the third root by comparing with 36. In that case, it was x minus 3, x minus 3, x minus 4, right? So this times 4 was minus 36. That's how we got it, right? Now we have to look for more combination where we get minus 36. So x minus what and x minus the same whatever it is here, and times x minus whatever number makes it 36, negative 36. So we can see that means there should be a perfect square for 36. Let's use what we used to do in our childhood. 36, let's do prime factorization for this. We already see I can already see 9 times 4 is 36. 4 is a perfect square, so it can be a 2, 2 and 9, right? 2 times 2, 4, 4 times 9, 36. So I got the first one. This is the, are they saying the list? In each case, state all three integer roots. Okay, so roots will be 2, 2 and 9. They are the roots. So this is our first set of roots, and then we will do 3, 3 and 2, 2. Okay, so we got pair of 3, we got pair of 2, we can also get pair of 1. Yes, so we can also get x minus 1, and x minus 36. Yeah, this multiplication is 1 times 1 is positive 1 times minus 36 is minus 36. Yeah, in this case the roots are 1, 1 and 36. Is there any other combination? Yes, 3 times 2 is 6 and 3 times 2 is 6. Yeah, we can get 6, 6 also. So third one will be x minus 6, and it is already 36, so x minus 1. Okay, so roots will be 6, 6, 1. Here the roots were 1, 1, 36. So we used common sense logic to find these three set of roots.